Hello guys, so in this video we have to find this indefinite integral as a sum of power series. So basically we have to represent this integral in the form of summation series. So we know, so here we will use the infinite geometric sum again. So we know that 1 plus x square plus x cube plus up to infinite terms. So this is 1 divided by 1 minus x, and this series can be represented in the form of summation as n is equal to 0 to infinite, that is x to the power n. So basically we will use this result to solve these questions where mod x is less than 1. So this is the interval of convergence for this series. So first of all we will solve this by just removing the t. So here if we will just replace x by t to the power 5, then what this whole term will become? So we will write it again, 1 divided by 1 minus t to the power 5. So it will become as t is equal to 0 to infinite. So here we can write it as t to the power 5 to the whole power n. So what it will become? It will become as t to the power 5n. Now if we want to just get this term t in the numerator, then we have to multiply t by both sides. So if we will multiply t by both sides, then it will become t divided by 1 minus t to the power 5 sigma n is equal to 0 to infinite. So this will become t to the power 5n plus 1, because if we will multiply t in t to the power 5n, so powers will add because the base is same. So now we have to integrate both sides. Integrate with respect to t both sides. So if we will integrate this term will become t divided by 1 minus t to the power 5 dt. So this is the main question. Now we have to integrate this summation series. Integration t to the power 5 n plus 1 dt. So this is the simple integration, linear integration. So power will add in numerator. So it will become sigma n is equal to 0 to infinite. So it will become t to the power 5 n plus 2 and divided by 5 n plus 2. So this is the representation, summation power series representation of the indefinite integral, and this is the answer. So if you find any query in this question, please do write in comment box, or if you would like to ask any other doubt, then please visit our website and post your query there. Thank you very much.